Hi guys, today is day 32 and we're looking at lesson 80. So adding and subtracting mixed numbers and polynomials. Poly just means many, and we'll explain what a polynomial is. We've worked with them before, so nothing new. Now we're just going to put them in. So when we have mixed numbers and or mixed units, mixed measurements, hours and minutes, or yards, feet, and inches, or something like that, we want to just add them like we do any number. We work right to left, but then we may have to change. It's like when we're adding a number, if it becomes greater than 10, we carry the 1 to the next place value. So it's the same thing here. So if we're looking at example 1, competing in a triathlon, Regina swam for 27 minutes, 15 seconds, biked for 48 minutes, 28 seconds, and ran for 42 minutes, 53 seconds. What was her total time in the triathlon? And we already have it set up here. We would just take the first time, second, third. Minutes and seconds. So we want to just add seconds. 15 plus 28 plus 53 is 96, which again is greater than a minute. So we'll adjust that in a second. And 27 plus 48 plus 42 minutes is 117 minutes, 96 seconds. 96 seconds is above 60 seconds, so this is really 1 minute and 36 seconds. So we add that 1 minute to 117, so we now call it 118 minutes and 36 seconds. And again, since we have another unit in time that we use, hours, and 118 minutes is greater than an hour, and we're going to call this an hour and 58 minutes, because it's not quite 2 hours, so hour and 58 minutes, and then 36 seconds would remain. So 1 hour, 58 minutes, 36 seconds. And then if they were keeping, I've never competed in a triathlon, but I don't know, they may keep track of the tenths of seconds or hundreds, but I bet they just take it out to the seconds. So that's where you would end. For subtracting, so let's look at this one. Junior weighed Junior weighed 7 pounds 12 ounces when he was born. Now he weighs 12 pounds 5 ounces. How much weight has Junior gained? So we want to find our range. We want to subtract our minimum or our starting birth weight from where we're at now. So we're going to subtract the lower number from the higher number. So 12 pounds 5 ounces minus 7 pounds 12 ounces. Okay, now just line up, just like we line up our place values when we're talking about decimal numbers or mixed numbers or whatever, we have to line up our units as well. And pounds are greater than ounces, so we put it to the left of ounces. And then we may have to look at the reference sheet to figure out, oh, I don't remember how many ounces are in a pound. Because in this example, well, we start at the right and work to the left when we're adding and subtracting. We have them stacked on top of each other. So 5 ounces minus 12 ounces. Well, 5 minus 12 is a negative. Obviously, he hasn't grown negative. He hasn't lost weight, you can tell. So what we do is we borrow a pound from 12 pounds. So now this is 11 pounds. And we add that 1 pound over here. We're going to put it in the form of ounces. So that's 16 ounces. And now this becomes 16 plus 5 is 21 ounces. So just write it over here. So 21 ounces here. So we added a pound over here. So instead of 1 pound 5 ounces, we're going to 21 ounces. So 21 minus 12 gives us 9 ounces. And then 11 pounds still minus 7 pounds is 4 pounds. So 4 pounds 9 ounces. That's how much weight he's gained since he was born. And then again, looking at it, ounces and pounds, if it was like 17 ounces or something like that, we were adding and we got over 16 ounces, then we would need to add it to the pounds category, but this one we ended up with 4 pounds 9 ounces, so we don't need to simplify that at all. Minutes and seconds is another common one that we have. So last year during physical fitness training, Marissa completed a mile in 12 minutes 15 seconds. This year, 9 minutes 48 seconds. Marissa improved her time by how many minutes and seconds? 2. Nine minutes 48 seconds. Let's start to the right. Well, all the way to the right. 15 seconds minus 48 gives us a negative number of seconds, which doesn't make sense for this. So we borrow a full minute from 12 minutes, so it leaves us with 11 minutes. We add that in the form of 60 seconds, so 60 seconds plus 15. Now this becomes 75 seconds. So we do our 75 minus 48, and that is 27 seconds, and then 11 minus 9 is 2, which is improved 2 minutes and 27 seconds. Okay, next concept we're looking at is polynomial. So poly just means many. So this can refer to a monomial, mono, something that has mono in it usually refers to one. So a monomial is just one term. So even though 2x cubed, for example, has the 2, the x, and the cube, it's still just one term. We're not multiplying or anything else to it, so that's one term. Negative 5 is one term. X squared y is one term. 7xyz is one term. Z is a monomial. A binomial, again, bi like a bicycle, two wheels. Bi means two, so a binomial has two terms. X plus 5. X plus the 5. If it's just 5x, 5 times x, we would just call that a monomial. Again, understanding the terms is important. It's not, if you forget what's a monomial, what's a binomial, just understanding the different terms is the main thing I want to get at. So xy minus 7y, x squared minus 4, those are all binomials. There's two terms. Three terms, trinomial. So x squared plus 7x plus 2, x plus 2xy plus y. And again, if it's addition, like these examples, we can add in any order. Usually we put the value with the highest value or the highest degree, the highest exponent, x squared, furthest to the left. And then the next one, 7x, x to the power of 1, so that would be next. And then our constant, or just our number, our constant would just be right here. So commonly you'll see a lot of, when you guys work with quadratics, you'll see a lot of trinomials, and this is the order we usually write. If we said 10 plus 7x plus x squared, that's not incorrect. We just want to have it in this form because down the road you start to break apart into multiple two binomials and do a bunch of different stuff with it. So the degree of the polynomial is the highest degree of any of its terms. If a term has one variable, the degree of the term is the exponent of the variable. So y, or y to the power of 1. So that's the degree. Squared, or to the power of 2. That's the second degree. 3, that's to the power of 3, or cubic. So we just look for those and again try to put them in that order because that'll help us down the road as we start to solve quadratics and things like that. Sorry, I kept bouncing back and forth. So for AC, well, a to the power of 1 and c, well, 1 plus 1 is 2, so the degree of the term is 2. X, Y, Z, they're all to the power of 1, but 1 plus 1 plus 1 is 3, so the degree of the term is 3. Now, a squared minus 4, we have to the power of 2. This is just a constant, so you can count m plus 3, 5a, b, c. We have 1, 2, 3. So again, that's just the degree. And then we write in order from left to right. The highest degree furthest to the left, and then working left to right, descending. Name the degree of each polynomial. So 4x3, again, we're not multiplying, so we don't say 3 plus 2 plus 1. We just say 4x cubed is our highest degree, or our highest exponent. So it's third degree. X squared minus 2x plus 3, x to the power of 2, so it's a second degree. X plus y, 3, first degree. And as we said, we write them in descending order. And then reordering them, again, just pay attention to signs. In this example, they're all addition, so that makes it pretty easy. Again, when we're combining like terms, which this one we don't have any like terms, the 2x cubed would be first, and x squared would be next, and then x to the power of 1, so a degree of 1, that would be third, and then our constant, or just our number, 2, would be at the very end. And so these are the same things. So this one isn't technically wrong, it's just we want to put it in this form so it's in descending order, because that makes a lot more sense, especially for with equations and graphing and things like that you guys will do a lot of down the road. Then if we have binomials or trinomials or whatever we're adding, we can do that. We combine like terms of x plus 6 plus 2x minus 3. I know if I'm adding these two binomials together, well, I'm adding them together. Now if I was adding, or if I was subtracting, I would have to pay attention, because I'm subtracting this entire binomial from this. But in this case, we're adding, so positive sign makes it a little bit easier. If it was a negative sign, we'd have to count for that. I'll show you in a second. So this one, x plus 2x, again, like terms, are x to the power 1, x to the power 1. So I have 1 here plus 2 here. That means I have 3. 6 minus 3, 6 minus 3 is positive 3, so 3x plus 3. Now what I meant is if we have let's say we have this binomial minus this binomial. Well, I'm minusing all of this, not just the x, not just the 2. I'm subtracting the entire thing. So how do we write this? X plus 2 minus x, and then minus negative 2, which is plus 2. I have x minus x, which is just 0. 2 plus 2, which is 4, so that would be 4. So if we're subtracting, just pay attention to the signs. Don't just say, oh, well, just write this binomial and this one and then combine like terms sometimes. But if you have this negative sign, you're subtracting these two terms from these two terms. So just be aware of that. All right, that practice set we will go over together, and we are nearing the end of the semester. So hooray, good job, you guys. See you soon.